this question, I'm going to prove the circle theorem that the angle at the centre is twice the size of the angle at the circumference when they are both subtended by the same arc. To do this, I'm going to start off by labelling this angle here as A. I'm then going to split this shape down the middle here to create two triangles. Now, these two triangles are both isosceles triangles, and I know that because A to O is a radius, B to O is a radius, and C to O is also a radius, which means all of those lengths are the same. So I'm going to add these little dashes onto here to show that those lengths are all the same, and I'm then going to label some angles. I'm going to label this angle as X, and I'm going to label this angle as X, because they must be the same, because they're isosceles triangles, and this is Y, and this is Y. I'm then going to label this angle here as B, and this angle here as C. Now, because angles in a triangle add to 180 degrees, I know that B plus 2x must be equal to 180 degrees. I also know that C plus 2 lots of y must equal 180 degrees. And the reason I know these facts is because these here are both triangles and the angles in a triangle add to 180. I also know that A add B add C must be equal to 360 degrees. And I know that because here I've got the angles around a point, and angles around a point always add to 360. Now I'm going to rearrange these first two equations that I have written here. I'm going to rearrange the first one to make B the subject. So B is going to be equal to 180 subtract 2x. And for the second one, I'm going to make C the subject. So C is going to be equal to 180 subtract 2y. Now I'm going to substitute what I have here, 180 minus 2x and 180 minus 2y, into my b and c in this equation here. So I'm going to end up with a plus 180 minus 2x plus 180 minus 2y equals 360. I'm just going to simplify this left-hand side slightly. So I'm going to get a subtract 2x, subtract 2y, add 360 equals 360. Now, because I have 360 on both sides of my equation, I'm going to subtract it from both. That's going to leave me with a subtract 2x, subtract 2y equals 0. I'm then going to add the 2x and add the 2y to both sides to give me a equals 2x, add 2y. Factoring out the 2 on this right-hand side, I get a is equal to 2 bracket x plus y. Now, going back to our initial labels on our diagram, a was this angle here, which was the angle at the centre, and x and y were the angles here that together create the angle at the circumference of the circle. And we've now proved what we wanted to prove. We've ended up with the fact that a is equal to 2 lots of x add y. So the angle at the centre is equal to 2 lots of the angle at the circumference.